Thanks for being here. One of the many things we can learn from Deborah's talk and stumble upon experience, 14 years experience, is that building machine learning application on production is tough. It's very tough. But the good news is that, guys, you don't need to build a solution from scratch. You can use existing machine learning server. So we PredictionIO, we built a machine learning server. The goal is for developers and data scientists to build machine learning applications on production in a fraction of the time. PredictionIO is now showcased by GitHub as one of the most popular machine learning products in the world. And today, I'm really excited to tell you the latest development, the features that we have. We have made major revamp from 0.7 version to 0.8 version. You will be a great contributor. You can add it into it. So before I jump into the features, the new features, I want to answer one question first. Why do you need a machine learning server? So what is a machine learning server? If you're familiar with the data science open source ecosystem, you must be aware of a lot of names. Like data processing, you have Apache, Hadoop, you have Spark. Machine learning libraries, algorithms are no longer a secret, right? You have Apache Mahout, you have Spark MLlib. As Deborah said, like they're standard algorithms, collaborative filterings, class regressions, they're out there, already there. And data storage, just like them, they use Cassandra, they use HBase. See, I can predict what stack they're using. But what is really missing is something that would put all this stuff together and make them talk to each other nicely so that we, developers, data scientists, can build something, not only prototyping, but something on production. Remember the architecture that they show you, right? Like stumble upon using. A lot of tools, putting them together, working together is challenging. And PredictionIO, you can just install it and everything will be in place. But what do I mean by prototyping and production? Let me give you an example. So the textbook case, classic recommender system, right? If you look up a tutorial, machine learning tutorial, Spark, MLlib, Hadoop, they will show you how to build a recommender system. So basically, they're showing you how to build a stumble upon. Well, not the recommendation discovery, but the same thing. They're telling you that you can build it with a few lines of code. So that's prototyping. I'm going to show you how it works. You have a mobile application, right? Like stumble upon. There's a mobile application. And you have content. So you want to build a recommender system or recommendation engine, whatever you call it. Now you feed in the user behavioral data or the content into the engine. And the engine will train the model with some algorithms. And then you want to predict what content a user would like. So now, as I mentioned, you don't need to build your algorithm from scratch, at least at the beginning. Like later on, maybe you want to build something fancy, but at least at the beginning, there are a lot of algorithms available. Spark MLlib has been built in PredictionIO, so we just take them as an example. If you go to the website, you'll see a tutorial using Spark MLlib built like recommendation system. It looks really easy. It looks. So your mobile application connect to Spark MLlib, got a predictive model, and you get prediction. Wow, so simple. So why is stumble upon you spending 14 years building this kind of stuff, and Deborah still working on it? Let me show you the code for this prototype, OK? I'm really glad to be here in SF Scala, so I don't need to explain the Scala syntax. Isn't it great? Like, Scala is a great programming language. We really love it. So, ready? The first line of code is you read data from a file. It can be a text file. It can be HDFS. As long as the data is well-defined, you're fine. So you just read the data. And then what do? You pass the data to an algorithm. So in this case, we use ALS, one of the matrix factorization algorithm, integrated in Spark MLlib. So it's really easy. You pass the data in the algorithm. It gives you a predictive model. Done. With a predictive model, all you need to do is pass all the users, loop through all your users, and make recommendations for them. So let's say you have 1,000 of users. You loop through them. You would get like 5 recommended contents for each user. So that's the end of the story. Machine learning prototyping. And you happily have a recommender system. What's wrong with it? Nothing wrong. It's great as a prototype. But moving beyond prototyping to production, now we start to scratch the head. How do you deploy it as a service so that you can respond to dynamic prediction query? Oh, it's back up. OK. So how can you do that? Like, let's say you want to recommend or discover 5 content to a user, free content to another user. Or if you're in San Francisco, right now, tonight, I want to recommend something to you. It would be very different from the content that I want to recommend to another user who is now currently in New York or whatsoever. So it's like dynamic response, dynamic recommendation. So you need to deploy the engine as a service. And also, you need to make the predictive model persistent, right? Like, you can't just have a model loop through all the users. You need to make it persistent in a distributed environment. And as I mentioned, like, there are a lot of great tools, HBase, Spark, algorithm libraries, or other tools. They're not great for being user-friendly, unfortunately. Like, getting them to work together is challenging. And there are a lot of other questions, like how do you prepare the data? Remember I mentioned prototyping, they require the data to be in really well-defined format. But most of the time, you're collecting data from multiple sources with different formats, like this user click this button, this user do some other behaviors. How can you collect the data in real time, and eventually you can update the model with real or new data? And also, like, from the software engineering perspective, if you guys are thinking about like really building recommendation system on production, now you're asking, OK, so where should I put my business logics? And how about like making it reusable, modularized, so that I can maintain it easily? And if you have a background in web development, mobile application development, now you're asking, where is the separation of concept framework? Like, we have the MVC for web development, but where is the MVC for machine learning? Like, we only have an algorithm, generate model, but where's the framework? So I'm going to show you what I think it should look like for machine learning to be on production. It should be just 2 circles, very easy. One is the event server. Event server collects all types of data. And there will be an engine. Engine represents the prediction engine, the predictive model. And it will be deployed as a service. So in real time, it can respond to data. Your mobile application will be sending the user behavioral data in real time to the event server. The engine will be able to pull the data from the event server and build the model and be a service, so that the mobile application will be able to send a real-time dynamic query to the engine. And then the engine will be able to respond to the application with a JSON response, and things like that. And it should be able to deploy it in a distributed environment. That's what we want, and that's what we want to provide to you, everyone who is building machine learning applications. So again, the goal of PredictionIO is focusing on building and deploying machine learning things on applications on production. And what's great about the stack, the open source stack, is that if you install PredictionIO with one line of command, you get the Apache Spark, you get the HBase, you get the Elastic Stack, all completely available with one single line of installation. So if you're starting a new project, that's a great way to start it. You get the latest technology because we abstract all these great tools underneath, so you can use it right away, and you won't worry about scalability forever, hopefully. So I talked about two components, right? Two main components. One is the event server. The other one is an engine. Now let's talk about the event server because it's the most simple component. Event server is the one that collects data from your mobile application or from your website or from your wearable device. After you install PredictionIO, launching an event server is very easy. You just run a command pio event server, and you got an event server. It's a very, very flexible way to collect data. And the data will be stored underneath in HBase in an event format. So for example, you want to collect events or actions. A user 1, 2, 3 give a rating of 5 to a product, to a content, 100. You just use the REST API or one of the many SDKs provided by the community, like Node.js SDK, Ruby SDK, Scala SDK, of course. And then you can collect the events to the event server. It's a really generic way to do it. If you have used analytical tools like Google Analytics, Mixpanel, or things like that, it's really, really similar, and it's generic. But are you ready for the fun part? Yeah. So we're going to talk about building an engine in Scala. So a little bit of deep diving into the code. Bear with me, because this is the MVC for machine learning in Scala. So we developed something called DASE, D-A-S-E. It's basically the MVC for machine learning. But I find it sound much better than MVC, right? DASE, you can pronounce it. MVC, you can't pronounce it. So D stands for data source, data preparation, which is responsible for preparing the data for training the model. A is algorithm or algorithms. So in an engine, you can have more than one algorithm, and you can evaluate them, you can combine them together. Which is really a really common practice, that you start with one simple algorithm, and you want to evolve and test other algorithms. So we provide a separation of concern. You don't need to worry about merging the code or whatsoever. And then S stands for serving. So this is where you put the real-time business logics. It's a serving component. Before you serve the prediction result, you can add whatever business logics to it. E stands for evaluation. So eventually, you want some evaluation of your prediction results. So I'm going to talk about two functions of an engine. So we're not going to touch upon evaluation tonight because we don't have enough time. But we can talk about the two main functions that an engine can perform. The first one is train a deployable model. The second one is, after you deploy the model, how does an engine respond to the real-time query from a mobile application? Part one, train a predictive model. Now, you can see that we separate the components into different classes: data source, preparator, algorithm. And in each classes, you have the functions responsible for different things. So let's assume I'm building a recommendation engine. I defined these classes. And then on PredictionIO platform, I just need to run the command pio train. What it does is it will trigger the retraining of data source, which would pull data from the event server, and then prepare it to make it like the training data format. And once you return the training data in the retraining function, PredictionIO will pass it on to the prepare of preparator automatically. And if you're familiar with Spark, you might have heard of RDD, which is a distributed data format. So training data can be an RDD format, which means that you can basically pass huge amount of data from it. But of course, like most of the time, training data, it depends on your application. Some of them you can do it in single machine, but most of the time you might want to do it in a distributed environment. So it has been taken care of. The RDD will be passed to prepare of preparator class. And prepare will take the training data and do whatever preparation you like. So you can do the data cleansing here, you can reformat the data here, remove anything that you don't like here. And you pass the returned prepared data. So the function will just need to return the prepared data. PredictionIO will take it and automatically pass it to your algorithm classes, to the train function of algorithm classes. As mentioned, you can have more than one algorithm, but in this example, it's just one algorithm, algorithm 1. So train function of algorithm 1 class will take the prepared data, and you can do whatever you like to build a predictive model, and you return the model. A closer look at the retraining function of data source is, it's very simple to the prototype that you have seen. Basically, it will use the events API provided by the event server of PredictionIO, get the storage of it, and then you find the events you like. And then you reformat it to a format that is required by the algorithm and return the training data model, object, sorry. And another deeper look is the train function of algorithm 1 class. Again, you remember the ALS function, right, in the prototype I've shown you before. It's basically just the algorithm function provided by MLlib. So here, you take the prepared data, do whatever you like, train the model, and return the model. PredictionIO platform will help you to make the model persistent and deploy it as a service automatically. So it will be in memory, it will be distributed. You don't need to worry about like, how do I retrieve the model when I'm serving prediction in real time. It's confusing, but you need to look at the source code. A better way to understand it is a visual view of an engine for the train predictive model process. It's the D components and the A components: data source, data preparator, and algorithms. When you trigger the PIO train, data source will pass the training data to data preparator. Data preparator will pass the prepared data to one or many algorithm classes that you have defined. And in the algorithm classes, they will produce models, and PredictionIO will store the model and make it deployable. That's training. The logic is very similar to what you're doing in the prototyping stage, except it's a separation of concern. So some of the data scientists can be working on one algorithm, while another data engineer doing the data cleansing can be working on the data preparator. Or like if you want to make the data source reusable for another project, you can just take the component, put it on another project. It's exactly like what MVC is doing for web development. So now you have an engine that is deployable. You have deployed a model. What does the source code looks like in an engine that is responsible for responding to real-time query? When I say query, it means that the input from your mobile application to the engine to request something. In a recommendation engine scenario, one of the possible ways is I give you a user ID. I tell you how many products I want to recommend to this user ID, and you return something to me, right? So the JSON request through REST API would probably be a user and a number of products. To take this JSON, all you need to do is to define a case class called query in your engine code. And obviously, you define a variable user, and you define a variable number, and make it serializable. PredictionIO will automatically load the JSON data that is sent by the REST API through the REST API interface into an object of this case class and pass it to the components that you have built. And similarly, to the output, we want to output a list of products. After prediction, after we predicted what products we want to recommend to this user ID, we want to pass a list of items with a score. The score would probably be like, the higher the score, the more likely the user would like it. So again, you define a case class, predicted result. Define an array, which means that is a list of products, basically. Make it serializable. And of course, you define what does it mean. What is it in the array? It is a string of an item ID, and a score. So that's it. In the engines, all you need to do is return a predicted result object. The platform will automatically convert it to a JSON format and return it to the mobile application through the REST API. So in terms of the code, we're actually triggering the A component again, but this time not in the train function, but the predict function. Let's say your mobile application create a query through the REST interface. The query, as mentioned, the JSON query will be transformed to a query object, pass it to the predict function automatically, along with the model that you have built before. With the model, with the query, you can make prediction, and you return the predicted result. Predicted result will be passed to serving, the serve of serving. Why is that? Because you can have multiple algorithms. So all the predicted results from multiple algorithms will be passed to the serve of the serving class as a sequence. And you can combine them, you can compare them, you can do whatever you like. And here you might want to add some real-time business logic here as well. Like in a recommendation case, if you don't want to show the products that are no longer available or like not in the inventory, this is where you put the business logics. So you won't be messing up the code of the algorithm plays or the data preparation case, and you can have different people working on different business logics. A closer look to the algorithm predict function is take the query, take the model. The model, remember, we used the ALS model of MLlib, right? You can use any other machine learning libraries, like deep learning library, Apache Mahao, any kind of library, you can use it. So take the model, just use the built-in function predict, recommend products. You return the result as a predicted result object, and it will be passed to the serving. So a summary of what's happening in a deployed engine responding to real-time prediction query is you trigger the algorithm class and you trigger the serving class. A query will be passed to the algorithm class that you have defined it, which contains the model. And then you will return the predicted result to serving. And serving will return a final predicted result object, which will be automatically converted to JSON response. And of course, you can have multiple algorithms here. So this is really beautiful. Like you're not only prototyping machine learning, but you have a framework, you have a design pattern that is reusable, modularized, providing you separation of concern. And that's really the new core features of 0.8 of PredictionIO. So if you're starting a new project, like you don't need to build everything from scratch. This is the framework with Spark, with HBase, with Elasticsearch, with a separation of concern for your development. And in the engine code, what bring all this component, DASE component together is a simple object called factory, pointing to all the classes. And now you have already built a production deployable recommendation engine in Scala. Running it on production in a distributed environment is very simple. One line of code, as mentioned, one line of command, you can install the whole stack. PredictionIO, Spark, HBase, Elasticsearch, everything talking together nicely. Event server. One command, you start an event server that can collect almost any kind of event in a really scalable way. Build the engine, have fun, is Scala, so you can look at the source code, modify it, change it. And once you have got the engine, you run PIO build to build the engine. You run PIO train the model. you run PIO deploy the model on production, you can deploy multiple instances on a large-scale cluster. And if you have new data coming in a batch mode, all you need to do is run PIO train again and then deploy it. It will automatically replace the old model with the new one. Of course, we're also working on the real-time streaming part, which is really sexy in the industry. And I'm glad to hear that StumbleUpon is also looking at it. We definitely love to get more feedback on it. So this is what we envision in the production environment of machine learning. Not only would you have one mobile application, like StumbleUpon, you might have mobile application, website, email campaign, basically whatever channels you're interacting with your users. You collect all the data to a simple event server through REST API SDKs. And then under the event server, within PredictionIO ecosystem, the platform, you can build multiple engines for different type of prediction problems. You can have one engine for recommendation on the front page, another engine for discovery, serendipity on another part of the front page, one for the email campaign. You can have fraud detection, churn prediction. Basically, you can use different type of algorithm in this really flexible framework. And it's all, again, the code is giving you the separation of concerns. And scalability has been taken care of automatically by the framework. So if you like what you see, if you think it's an exciting project, the next step is don't worry about the complexity, because we provide templates. You don't need to write things from scratch. We have templates for recommendation. We have templates for classification. We even have templates for some business logics, like discovering similar products and things like that, all written in Scala. And you can just go to the GitHub, look at it, see how the DASE components are working, and subscribe to the newsletter on our website. If you're sitting here, not knowing Scala, just coming for the food, I strongly encourage you to learn Scala. It's a beautiful language. And finally, it's a privilege to share PredictionIO with you guys here. We need more people who understand Scala, interested in machine learning, to participate in the project. Tell us things like, from the small things like your documentation, this here you need improvement, to contributing to the whole architecture, to machine learning algorithms, deep learning, streaming, anything. We really need help. It's a very early stage product, but at the same time, right now, it's powering hundreds of applications, including one of the largest media company here, many like e-commerce, large-scale media and e-commerce companies. So it's an exciting project focusing on production. Thank you. Any questions? Yes.
How did you make it scalable?
So the question is, how do we make it scalable? We depend heavily on Spark. So as long as you're following the RDD formats of a data transformation, we're as scalable as Spark. So basically, in the early version, we support Hadoop, but now we believe that Spark is more suitable for machine learning task. It's not saying that we won't support Hadoop. It's basically portable. You can port to Hadoop as well.
A couple of questions. So how do you actually scale it for online serving? Like, for example, you have a REST query giving the engines. So do you take care of all the load balancing and everything also, or is it something you need to do?
So the question is, how do we make it scalable in terms of the online serving prediction query? Let's say like trillions of requests at the same time. I mentioned that you can deploy the engines, the model, to multiple servers. So how do we do it? Again, Spark is distributed in the project. We love them, we work with them. So the model you build actually resides in Spark, in memory, in the distributed cluster. And you can deploy engines on the same engines on multiple servers. And we have a cluster on AWS where you can just use a few clicks, you can launch the whole distributed cluster. If not, after you deploy the engines on multiple servers, you can use op tools like Chef or like other things to point it to different servers, engines to do load balancing. So, and also we have a very lightweight layer handling the REST API interface. It's the PredictionIO framework. So it's very lightweight and it can serve a lot of requests. Hi, sorry.
Yeah, I was just wondering again on the scaling and sort of the operational aspect of it. How much do you have to know about the underlying technologies? Like, does it use Zookeeper? Do you have to know how to set that up, or is it taken care of for you? The sharding, the data, is there strategies for doing that?
Yeah. So the question is, there are a lot of technology underneath, like Spark, Zookeepers, and things like that. Do you need, how much you need to understand those technology in order to use PredictionIO? We spend tremendous amount of time making sure that all the components are talking together nicely. PredictionIO is one of the few products nowadays certified on Spark. So we're compatible with the latest Spark specification. We make sure that the version that you're using, MLlib, HBase, Spark, Elasticsearch, and PredictionIO server, all talk together nicely if you install a clean installation. But if you have existing like Cloudera, HBase, or things like that, we're also happy to help to support as much as possible. So one of the very main missions of PredictionIO stack is we want to do the heavy lifting for developers, for data scientists. Like modeling, finding smart data is fun. It's the job that data scientists would love to do. But like setting up zookeepers, making sure things are scalable, this is stuff that should be taken care of by software and also by maybe one or two experts in a company, but not a job of a data scientist, we think. Thank you.